Hey guys, let's take a look at reciprocal and quotient identities. So the reciprocal identities you already know. Sine and cosecant are reciprocals of each other, so that means that sine is equal to 1 over cosecant, and cosecant is equal to 1 over sine. Cosine and secant are reciprocals of each other, so cosine is 1 over secant, and secant is 1 over cosine. Cotangent and tangent are reciprocals of each other, so tangent is equal to 1 over cotangent, and cotangent is equal to 1 over tangent. However, when it comes to those tangent identities, when you start thinking of those, instead of thinking cotangent as 1 over tangent, I would want you to think of them as sine over cosine, and cotangent as cosine over sine. So here's why. Remember, tangent, when we would find tangent in our on our unit circle, we would take our y value and divide by our x value, right? So we have sine over cosine. And since cotangent is the reciprocal of tangent, that is cosine over sine. So those I would commit to memory. You are going to use those a whole lot. Okay, so start off nice and easy. If cosecant is 7/4, find sine. So we know that cosecant and sine are reciprocals of each other. So if cosecant is 7/4, that means that sine is 4/7. There's the reciprocal of that. Now, one thing I want to be clear about is that it does say that cosecant is equal to 1 over sine, okay, or sine is equal to 1 over cosecant. I want to be clear that if you were to give me the answer of sine is equal to 1 over 7/4, that's not okay. You need to flip and multiply that fraction on the bottom to get 4/7. So this is not allowed. Don't do it. Okay. Then if cotangent is 3, find tangent. Go ahead and try that one on your own. Yeah, so it's just the reciprocal. So tangent of theta is equal to 1/3. Now let's go a little bit more complicated, having to use that quotient identity. So it says that cotangent is 2 over 5 square root 5, and sine is square root of 5 over 3, find cosine. So where some kids start to run into issues on these is they start to think of cotangent is cosine over sine very, very specifically. Like 2 has to be cosine because that's on top. 5 square root 5 has to be sine because that's on the bottom. No, remember, that's a ratio. And there's a bunch of different things that could simplify to give me 2 over 5 square root 5. So we need to know what sine is in order to solve for cosine. So first of all, let's remember that we know that cotangent is cosine over sine. So we'll replace in what we know. Cotangent was 2 over 5 square root 5. We're trying to solve for cosine. And it said that sine was the square root of 5 over 3. Now, with that square root 5 over 3, if you want to flip and multiply with that cosine on top, that's totally fine. But I noticed when we were having conversations in our last unit that if you were to be given something like this, it's more likely that you would go ahead and cross multiply right at this moment, which is totally fine. I'm good with that. So 5 square root 5 times cosine is 5 square root 5 cosine equals, and then 2 times square root 5 over 3 is 2 square root 5 over 3. So let's start solving for cosine. The first thing I want to do is get rid of that square root 5 because he's just a little bit icky. So I'm going to divide by the square root of 5. And over here I'm going to divide by the square root of 5, disguised as multiplying by 1 over the square root of 5. Square root of 5's divide away. Square root of 5's divide away. So now we've got 5 cosine of theta equals 2/3. So now we'll divide by 5 on both sides. Divide by 5. Divide by 5 multiplied as, or disguised as multiplying by 1/5. 5's divide away to 1. So we're just left with cosine over there on our left side. And on our right side, we're left with 2/15. This is just a whole lot of algebra. So get ready for algebra like on steroids. All right, so now let's talk about other IDs that you probably have not heard about. All right, so Pythagorean IDs. You probably have figured out that a Pythagorean ID has something to do with the Pythagorean theorem, and you'd be right. So here is our unit circle. Now, if we were to go ahead and make a right triangle inside of here, hang on, let me get this. If we count over, that's my x values, so that's cosine. When we count up, that's my y values, so that's sine. And then remember, it's called the unit circle because the radius is 1, right? 1 unit. So that means that the hypotenuse of this triangle is 1. So when we put it into the Pythagorean theorem, we would have sine squared plus cosine squared equals 1 squared, or just 1. Now, the way that we get all of these other identities is we take that original and we start dividing. So if we were to take sine squared and divide by cosine squared, sorry about that, sine squared over cosine squared gives us tangent squared. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So that's how we get tangent squared plus 1 equals secant squared. Similarly, we can take all these guys and divide by sine squared. Sine squared divided by sine squared gives us 1 right here. Cosine squared divided by sine squared gives me cotangent. And 1 over sine squared is cosecant squared. So that's how we get the rest of those. I'm going to go ahead and erase this. Cool. Okay, so now they're going to tell me that tangent is equal to -8. And sine is greater than 0, so find sine and cosine. So remember, tangent is two values that are going to simplify to be -8. It's a ratio. So remember, we can't just put -8 over 1 and call sine -8 and cosine 1. That's not really how that works. So let's take a look. So we have a value for tangent. So I would suggest using the Pythagorean identity that has tangent in it. Tangent squared plus 1 equals secant squared. Now we know tangent is -8. So we'll put negative 8 in for tangent. So we'll have negative 8 squared plus 1 equals secant squared. Negative 8 squared is 64. 64 plus 1 is 65. Now to get secant by itself, we need to take the square root of both sides. So remember, when we take the square root of 65, it's not just the square root of 65. We have a plus or minus there. So now we have to decide which one is it, plus or minus. Well, let's figure it out. Now, tangent was equal to negative 8, so we know that tangent is negative. And then since that sine is greater than 0, since sine is greater than 0, that means sine is positive. Now we have to figure out what is cosine. Now, the reason we're concerned about the sign of cosine, or the positive or negativeness of cosine, is because, remember, secant is the reciprocal of cosine. So whatever sign cosine has, secant will have the same one. So remember, tangent is sine divided by cosine. So if sine is positive, what do we need to divide by to get a negative number? Yeah, a positive divided by a negative gives me a negative. So that means that cosine has to be negative. So that means that secant is going to be negative. So now what we know is that secant is equal to negative square root of 65. Like, that's cool and all, but that's not what they asked me for, right? They asked for sine and they asked for cosine. So we know that secant is the reciprocal of cosine. So now we know that cosine is going to be equal to negative 1 over the square root of 65. Now, if you are passionate about rationalizing denominators, please feel free, but I'm not that concerned about it. The only times where I'm going to be concerned about you simplifying radicals or rationalizing denominators is only when it's a perfect square and it comes out really, really nicely. Like if you had that as the square root of 36, I would be unhappy with you. Tell me it's 6. Okay. All right, so we found cosine, but we are not out of the woods yet. We still need to find sine. Now, we know that tangent is sine over cosine. So let's write that down over here. So then we're going to replace in what we know now. I'm going to put a little line here to make sure that I'm staying separate. All right, so we know tangent is equal to negative 8. I'm actually going to put that over 1 just because if I have fractions, I like everything to be in a fraction. Sine is what we're solving for right now, so we're going to leave that alone. And we just figured out that cosine was negative 1 over the square root of 65. Like we talked about a minute ago, you are welcome to flip and multiply that fraction there on the bottom. But in our conversations that we had a little bit earlier, Edith went ahead and cross-multiplied, so I'm fine with that. 1 times sine is going to be sine. And then negative 8 times negative 1 is positive 8. Over the square root of 65. I don't know where all of my work just went. Back it up a little bit. Sorry. Okay, let's see if we can get through this one. So, secant of theta is equal to negative 5, and sine of theta is greater than 0. Find tangent and sine. So first of all, we're going to look for the Pythagorean identity that has secant in it. So that is tangent squared plus 1 equals secant squared. And then we'll replace in what we know. We know that secant is -5, so we'll square him. Now we'll go ahead and solve for tangent. So we know -5 squared is 25, and then we'll subtract 1 from both sides. Now to get tangent by itself, we're going to have to take the square root. And remember, when we take the square root, we should have a plus or minus out front. I'm not worried about you simplifying radicals unless they are perfect squares, in which case you need to tell me what the square root is. But with this, you do not have to tell me it's 2 square root 6. Cool. Now we have to decide, what is tangent, positive or negative? Well, in the directions, it tells me that secant was equal to -5. That means that cosine, his reciprocal, is negative. Sine was greater than 0, so that means that sine is positive. Tangent is sine divided by cosine, so a positive divided by a negative means that tangent is negative. So that means that we know that tangent of theta is going to be equal to negative square root of 24. So there's one answer. Now we want to solve for sine. So we know that tangent is going to be sine over cosine. And we just figured out that cosine was negative square root of 24. And then we have sine on top. Now we got to figure out what cosine is. Well, remember, cosine and secant are the reciprocals of each other. So if secant is -5, cosine is -1/5, or 1 over -5, whichever way you want to look at it. I'm going to pop that -24 over 1, and then we can cross multiply. 1 times sine is sine. -1 times -24 is positive 24, and that's over 5. So we have sine is equal to -24, and then also sine of theta is equal to the square root of 24 over 5. All right. So now what we want to do is we want to simplify the expressions. Now, getting to the answer is not the point here. Showing me your steps and what you replaced in is the point. We're working our way to essentially kind of a proof that we're going to do here in a couple of lessons. It's not going to be like in geometry with the 2-column proofs and your statements and your reasons, but it's still important to show all of your steps. So let's get started. So we want to simplify this. Cosecant, secant minus cotangent. So my advice is first turn everything into sine and cosine. So cosecant is the reciprocal of sine. So I'm going to rewrite that as 1 over sine times. Secant is the reciprocal of cosine. So that's 1 over cosine minus. And then cotangent, I know it's really tempting to tell me 1 over tangent, but remember, turn it into sine and cosine. Cotangent is cosine over sine. So now I'm just going to rock some algebra. I'm supposed to multiply those two fractions together, so that's what I'll do. 1 over sine cosine minus cosine over sine. Then we want to subtract these fractions, so that means we need a common denominator. So I need to multiply my second fraction by cosine. So we have 1 over sine cosine minus cosine times cosine is cosine squared over sine cosine. Now that we have the same denominators, we can combine our numerators, and we have 1 minus cosine squared over sine cosine. Whenever you see a trig squared and a 1, you should be looking for your Pythagorean identities. So we have sine squared plus cosine squared equals 1. Woo, so we're going to use that to help us. Sine squared plus cosine squared equals 1. Inside of our identity there, or in what we're trying to simplify, we have 1 minus cosine squared. So I'm going to rewrite that equation with 1 minus cosine squared. So that means we're going to have to subtract cosine squared from both sides. So 1 minus cosine squared is equal to sine squared. So we'll replace him in. Move him up here. We have a sine squared on top and a sine on the bottom, so that means that our sines can divide away. The sine on the bottom will divide away, and one of the sines on top will divide away. So now we're just left with sine over cosine. And we know that sine over cosine is tangent. Now, in our problems on Canvas, it's going to say this simplifies to, in this case, tangent of theta. Show me all of your steps. So you can either upload a picture by clicking on the Upload Media button in that problem, or you can type it all out using MathQuill. If you do type it out, my advice would be to, instead of using thetas, because that's annoying to have to click in every time, just replace the theta with an x. That is totally fine with me. Okay, let's look at this one. Now we have sine squared times cosine minus 1 over secant. So let's turn this all into sine and cosine. So sine squared and cosine are already in sine and cosine. But 1 over secant, remember, is the same thing as cosine. Sine, cosine, and cosine, they have a factor in common. It's cosine, so I'm going to factor him out. Remember, to factor out, we divide. So sine squared cosine divided by cosine is sine squared. Minus is in the middle. Cosine divided by cosine is 1. Now remember, I said whenever you see a trig squared and a 1, that means you have a Pythagorean identity. So let's look at that guy. We know that sine squared plus cosine squared equals 1. Where is it? There he is. Sine squared plus cosine squared equals 1. So let's mess with that. Now, in our problem, we have sine squared minus 1. So I'm going to subtract my 1 over. So I can have sine squared minus 1 plus cosine squared equals 0. Now I want sine squared minus 1 by itself, so I'm going to subtract cosine squared to the other side. So I know sine squared minus 1 is equal to negative cosine squared. So I'll replace him in. And then cosine times negative cosine squared is just negative cosine cubed. Awesome. Okay, this next one is super, super beefy. So first of all, we have sine cosine over 1 minus sine minus 1 plus sine over cosine. So those aren't sine squareds. We can't use Pythagorean identities. So we're going to want to get common denominators. So I'm going to multiply my first fraction by cosine over cosine and multiply my second fraction by 1 minus sine. Cosine times sine cosine. I'm going to have sine, and then cosine times cosine is cosine squared, over, and I'm going to keep that as cosine times 1 minus sine. I'm not going to multiply it out. Minus. Now those two are conjugates of each other, or you might recognize a difference of squares if you were to multiply them out and combine them. Either way, and you can feel free to multiply it out, we're going to end up with 1 minus sine squared there. Over cosine times 1 minus sine squared times sine. Cool. So now I'll replace in some stuff that we know. We have a sine squared and a 1 up there on top. So we know that cosine squared plus sine squared equals 1. So I can subtract sine squared from both sides. So I can replace 1 minus sine squared with cosine squared. So now we have common denominators. We can combine these together. I'm going to go ahead and factor out a cosine squared in my numerator. So sine cosine squared, divide out that cosine squared. I'm just left with sine. Then we have a minus sign. Cosine squared divided by cosine squared is 1. Now I'm going to divide away one of those cosines. So I can get rid of one of my cosines on the bottom, and that on the top, and that cosine on the bottom goes away. Now, here's something that I would love for you to notice. How could I rewrite 1 minus sine of x as some number times sine of x minus 1? Yeah, that number would have to be negative 1. And here's why. The sign on top up here is positive. If we divide by negative 1, boom, down here he's negative. The 1 down here, up here is positive. Down here is negative. I'm sorry. The one on the bottom is positive. So if we divide by -1, now they have the correct sign. So these sine -1s will divide away, and then cosine divided by -1 is negative cosine. Now that one was super beefy, so don't be too afraid of it. All right, I'll see you guys a little bit later.